Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 physical sciences exam prep on electric circuits. Today's question paper is the KwaZulu Natal province's physical sciences of September 2024. So, without any waste of time, by now I know you have done so many exam papers, you know the instructions. So without any waste of time, let's get into it. So question 8 says, the battery in the circuit below has an EMF of 5 volts and internal resistance small caps R. The resistance of the connecting wires and ammeter can be ignored. Okay, interesting. 8.1 state 8.1 state Ohm's law in weights. It says potential difference in a conductor is directly proportional. Let me write this down before I proceed. Potential difference in a conductor is directly proportional to the current in the conductor provided temperature remains constant. Provided temperature remains constant. Provided temperature remains constant, right? Good. Now, switch S is closed and the ammeter reading is 0.4. Well, this circuit is not bad, eh? This circuit is not bad. So let's see. So, switch S is closed and the ammeter reading is 0.4. 8.2.1, the reading on the voltmeter. Calculate the reading on the voltmeter. Okay, we may need total resistance because now that this guy S is closed, this voltage will change. So let's see, what does it change to? We need 1 over Rp, which is 1 over R1 plus 1 over R2. So now proceeding, we do not know what this 1 over Rp is. I will take 18 ohms as R1 and the 6 ohms as R2. When I look at it, this will become 1 plus 3 will become 4 over 18. 4 over 18 is the same as 2 over 9. So you have used your calculator. 1 divided by 2 over 9 will be 9 over 2. In other words, you will get 4.5. But let me not rush it and just write 9 over 2. Therefore, 9 over 2 is 4.5 ohms. We are not done. We are looking for the reading on the voltmeter. So we know R will be equal to V over I. But the R we're going to use, which is the external, is basically the RP, right? And the current that we're going to use is the one at the ammeter because this is the total current. We just found that the RP is 4.5 and the current flowing at ammeter A is 0.4. Now let's see. We need to say 4.5 times 0.4. It gives us 1.8 volts. Therefore, reading on voltmeter is 1.8 volts. Wow. Then this battery must be very hot. It must be very hot. I can see V lost is 0.2 already. Yo, that's bad. All right, 8.2.2. Calculate the energy dissipated in the 18 ohm resistor in 5 minutes. They said energy dissipated in 5 minutes, right? So here, energy dissipated, we need to be careful here. Energy dissipated is basically the amount of energy, right? Is the amount of energy. That's the most important thing. The question is not saying the rate at which energy is dissipated. So they're saying energy dissipated. So our answer must be in units of energy, right? The answer must be in units of energy. Our definition of our definition of potential difference is that it is potential energy. We said it is work done per unit charge. If you recall, it is work done per unit charge. All right. Now, what we are looking for is this work done, which is VQ. Now, Q, somehow we can relate it to current, right? When we relate it to current, we recall current equals charge over time. Let me just say delta T, implying we can say charge equals current times delta T. Let me substitute it, meaning we now have um energy dissipated equals voltage times current times delta T. But let's see, they said we need to calculate the energy dissipated in the 18 ohm resistor in 5 minutes. Do we know the current flowing in the 18 ohm resistor? We do not know it, right? We know the voltage and we know the resistance. We do not know the current. So let's try to replace this current with resistance and voltage. Of course, we will use this Ohm's law, right? So this means I equals V over R. And this says to us, we need to be saying, what do we need? This says to us, we need to be saying V squared delta T, all right? V squared delta T over R. Now we have everything we need. Let's go. What is the voltage? The voltage here, as you can see, it is they are connected in parallel. So the voltage here is the one read by voltage V, which was 1,8. So it'll be 1,8 square. And what is the time? Be careful with the time. It is in minutes. So what do we need? We need to convert minutes to seconds. So we'll say times 60. Right? We will need to say times 60. Right? Is that so? We need to say times 60. Then, what else do we have? We also have the resistance, which is 18 ohms. Right? Now let's get our answer. So 1,8 squared multiplied by this is 600. No, 300 all over 18. Our answer is 54 joules. Okay, so the energy dissipated is 54 joules. You guys get it now? Perfect. Now we can proceed. Now you know this. Remember, energy dissipated, not the energy, the rate of energy dissipated. This is saying energy dissipated, not the rate. Got it? Perfect. Moving on. 8.2.3. You see now we are on the 9th minute approaching the 10th. And we are done with 10 marks so far. We are on the right track. 8.2.3. Calculate the internal resistance of the cell. All right. So what we know that amp of the battery is equal to total current, open brackets, external resistance plus internal resistance. What is the amp of the battery? It is 5 volts. What is the total current? It's 0,4. What is the external resistance? It was it 4,5? Yes, it was 4,5. Internal resistance is unknown. Now, 5 divided by 0,4 will be 12,5. A bag of maize meal equals 4,5 plus R. Right? So 12,5 minus 4,5 will be 8 ohms. Right? Will be 8 ohms. Remember, this is internal resistance of the battery. But the question was very clear. It said the internal resistance of the cell. How many cells are making this battery? 2. So therefore, internal resistance of the cell is 8 divided by 2. Therefore, internal resistance of the cell is 4 ohms. So each cell has an internal resistance of 4 ohms. You guys got it? We are done. All right, so check this out now. We have saved about 4, 8, 12, 14. We have saved about 3 minutes. Let's go now to the last question. 8.3. How will the reading on the voltmeter V change when switch S is open? Choose from increases, decreases, or remain the same. When switch S is open, guys, I'm not giving you the answer as yet. When switch S is open, what's going to happen? R external will increase. R external will now be 6 ohms because there won't be any current flowing on the 18 ohm resistor. Current will just be flowing here. As you can see, the external resistance will be 6 ohms, jumping from 4,5. Right? So when this external resistance increases, what's going to happen to the total current? The total current will decrease. What happens when the total current decreases? The potential difference or internal potential difference will also decrease. And then what's going to happen to V load? V load in this case is what will be read by V here. What will it be? V load here will increase. Why does it increase? It's increasing because if you recall, let's go and show you. V load equals mth minus V internal. What happens if this guy decreases? Right? What happens if this guy decreases? If this guy decreases, the difference increases. All right? So when the difference increases, V load increases. Right? V load increases. Now to answer the question, our answer is increases. So do you see? I'm not just giving you an answer, I'm explaining how you got that answer. You guys happy now? Pet. So see you next time. Ours ends here. And bye-bye.